Okay. So first I'm going to invite up Kevin, and the reason why that we've asked Kevin to come, and Kevin and his team are part of the ecometrics tool, which Janine mentioned, and this was like a really exciting discovery for us in the process, this tool, because we were going to the primary literature to try to find the data, to look at the research that we could then provide to the design teams. And that was really, really difficult to do. And it became particularly difficult to do in some places, like we were asked to do a project in China, and they were like, not only could we have trouble finding anybody who could read Chinese, but there really isn't even that much written from an ecological perspective about the resources in China. So it became a huge daunting task to try to figure out how to get the literature to serve the numbers that we needed. And so when we discovered this tool, we were like, oh, really? I just need an iPad? So we're going to learn a little bit more about it.
Thank you, Dana. Okay, so I'm going to jump straight into this because I'm already at part time. I'm going to know. So we had a series of questions that Janine suggested, and being very literal, I wrote them out and I'm going to respond to them. So the first question was, what's the story behind why you want to create the tool, and what did or do you hope to accomplish? And it's actually kind of interesting. We started with this back in 2002. It was what kind of launched us. The Oregon Department of Transportation approached us and said, we have this bridge program. We have to replace 500 bridges. And it's going to be a permitting nightmare. So we need a process. And so we brainstormed and we thought, well, the first thing is you should try to get one permit process for all your agencies. Get all of the agencies together and focus more around an ecosystem, and then how those pieces of the ecosystem relate to all those regulatory processes. And let's get something a little more streamlined. And then we started thinking about it, and we thought, well, what about the mitigation side? We should be doing that on the mitigation side too. And so what that led us to was trying to figure out, so how do we measure ecological uplift, but then be able to trace all those aspects of that ecological uplift to the component regulations that they relate. And so that got us moving in this direction, which led us into doing a lot of work in ecosystem markets. So basically building debit credit systems. And that, was fulfilling. We were happy enough with that. But then we realized, wait a minute, there's something a lot more here. If you can measure ecosystem uplift and you can start to suss out the different elements of that ecosystem, that really lends itself to thinking about ecosystem services and measuring ecosystem services. So a lot of the things we were doing in that debit credit creation, we started moving into more of a decision support around ecosystem services. So when we measure ecosystem services, we're always thinking about, there's that value proposition. To understand that value proposition, you have to understand where the benefits are being produced and what the flow of benefits looks like on the landscape. But to understand that, you have to understand the underlying ecological processes, because those are coming together to create that benefit. But to be able to understand those ecological processes, you have to understand how landscape attributes are coming together to produce that. So that's basically where we ended up with. What did we accomplish? What do we hope to accomplish? What we've accomplished so far, and this is something that the Nature Conservancy and Dow gave a huge boost to, was they brought us in a collaboration to produce the EASY tool. The EASY tool took all of the systems we've been creating before and turned it into something that's a little more user-friendly, which was a big thing missing from our previous tools. And trust me, they weren't very friendly. This, as Janine was saying and as Dana said, it starts to bring that user friendliness into it. But what do we hope to accomplish? We're this far in something that needs to be taken that far. There's a lot of ways of thinking about different services. When you think about benefits, human benefits, that's a very subjective thing, and those benefits can be defined in a lot of different ways. So there are a lot of different ways of defining some of these services. Take aesthetics, for example. The Easy tool is built on behalf of Dow. Dow thinks about aesthetics as, well, we have these big, ugly buildings. They've got pipes and pumps, they're noisy and annoying to communities. Aesthetics for them is, do you have natural elements that are masking those buildings from communities? That's a very different way of thinking about aesthetics from like the Forest Service manager who's managing a scenic area, right? Very, very different. Well, at some point, you need to expand the tool to create a library, and this is something Ken kind of referred to this morning. You need as many types of models getting that, so defining the service very carefully in specific ways, and then identifying how you measure it to get at that particular aspect. And there are so many more to be built out. I'll talk about that a little bit more as we go. Okay, second question. Very literal, moving straight through it. Tell us what is cool and leading edge about your tool, and talk a little bit about what it looks like, how you use it. So I have a couple of examples, things that I think are neat about the tool. I mean, there's some basic things. It's publicly available, free, open source, things that I think are kind of a given need to be there. But some things, I'm going to just show a couple of different case studies of applications where you've seen how you can kind of use the tool in different ways. This first one was a watershed characterization in Java. The idea was there's a lot of flooding. This is central Java, Samarang city, largest city in central Java is to the north there, that big gray blob, and floods every year. So the goal was a flood risk reduction project. And this to me was kind of neat because when Sissel was doing her comparison of all the different tools, we were very specifically designated as we're a site tool. We can do site analysis, which we accepted at the time, but over time we've started thinking, well, we should challenge that. Are there ways of taking this site tool and using it at a landscape level, which is something we've always thought is critical because you have to connect scales. In most of the analysis we do, most of the projects we're working on, you can't just be at one scale. You have to focus at multiple scales. Well, what we did here was we used existing land use mapping that the University of Samarang had done, and thought through, okay, so these are the land cover types they have. Is that adequate? If it is, can we do a sampling of those land cover types around the watershed to identify whether there's a typical level of performance associated with that land cover type? So we did that. We ended up splitting out a couple of their land cover types and figured out where those were on the landscape primarily. But then at that point, now you have a way of taking that information and applying it, doing a watershed characterization with it. Right? So this is the result. When you look at that, there's the land cover map that the university produced. Now this is a performance map. That's a heat map. Darker the green, the better the performance. That's looking at a specific service, water quantity control, since this is a flood risk reduction project. And you can see there's a band there of green. That's an area where they have a lot of agricultural activities, primarily rice paddies. The darker red areas pretty much line up with where urbanization has occurred. That orange blob in the lower left, That's actually the remnant tropical forest. And your first thought would be, well, I would think that would perform well. Turns out the only place they have remnant tropical forest is where it's really steep slopes with clay soils. So, but what this did was it allowed us to characterize the watershed and start to think about, okay, so how is it performing? Using the tool, we did some calculations. We realized that the upper basin is currently sending down into the lower basin 8.25 billion liters when they have a 25-year storm event. But we're also able to think about, well, there's a lot of land use conversion happening at the moment. Basically, it's going from rice paddies are being converted to residential. Every time that happens, it quadruples the runoff from that particular parcel, which enabled us to start thinking about, okay, so what does that mean? What are the policy choices they have available to them? How should they be managing this watershed? We started looking at what are the mitigation activities they could do and how would those perform. It allowed them to start doing, to really apply both the site and watershed scale and relate them. Okay, the other thing I want to get to is, this is something we did with Disney. We have one of the models in the tool is it's a temperature model basically that measures localized temperature effects based on albedo, based on evaporation, based on shade, that type of thing. We link that to uniform thermal comfort index to actually look at how could they increase the number of usable days in an area by how they've landscaped it. So basically we link the output of the tool to that comfort index. It's a kind of a way to start getting it into urban design in some different ways. Okay, and I'm going to move through these. If you go onto the site, there's some video. These are two videos that kind of show what you see when you get into the tool. I think there's also some other materials that tell you more about the tool. So I encourage you to go in and look at those. A couple of things that are important. Dana was talking about the ability to measure trade-offs. When we do outputs from the tool, a couple of things. One is we always provide a measure of functional performance where we're measuring every service in the exact same unit. What that does is allow you to always look at, okay, so if I take this action on the landscape, where is that creating trade-offs that I need to be aware of? But we also always have an engineering unit, an absolute measure of output. So how many gallons per day, tons per year. And that really allows you to apply the outputs in different types of contexts to answer different types of questions. And then different formats, tabular, graphic, or spatial. And this is very important. Place matters when you're talking about ecosystem services. Is it adjacent to something that needs to be? What are the proximity issues? Okay, and question 3, what are the limitations? Where do you need help? And this is going to blend very closely with number 4. The first 2 bullets, basic points, caveats that are always out there. You need training to use it. It's hard to create these things to be perfect. But the third bullet is kind of the critical one. There's plenty of demand for ecosystem service quantification. There's very limited demand on the part of entities that want to invest in expanding these tools. And that's kind of where the difficulty lays, because this tool is only so useful in its current state. It's built for a specific context, and it makes it very difficult to apply it to all the other contexts, and every context is going to be different. The more you can expand the tools, get different models in them, and this is something that Ken referenced this morning as well, the more you expand it, the bigger the library, the more contexts it can be applied to, and the more it's a readily available tool for people to grab onto. So, final question, what if everybody used your tool? I think the big thing is increased development of new models and functionality, improved user capabilities, because now you have people being able to provide mentorship and training to people. You have a bigger community of users able to share ideas. You have expanded creative applications, because these tools can do a lot of different things if you're creative and figure out how to apply them to answer specific questions. And that really starts to expand. The impact for society, that list could actually go on for quite a ways. More informed decisions, increased sustainability, and improved resilience. But you could parse that out: improved health, improved everything that we're getting from nature. So that's it, and ran through that kind of fast. I would love to answer questions if anybody has questions about it. And I've probably just raised more questions than I've answered with this. But go into the website. There's a lot of information on the tool in there, and feel free to stop me and ask questions. Thank you.
So this really is a tool that you'll want to geek out with. When Jamie found it and, brought her little iPad and look, you can do this. And one of the cool things for us that we found so fascinating, you mentioned it, but it takes the ecological units and metrics and converts them into numbers that matter to engineers and designers, which is really important. And I think it's interesting that you've gone now from site and scaling up to landscape,